Ladies and gents, welcome back. So let's talk about some stuff for prepping for the future, which again is going to feature the Pythagorean theorem. And so all these problems are going to be linked in some way to that concept. So let's jump into it. So we need to find the links at two cables below. Please note the tower is at a right angle to the ground, and that's actually the part that is going to give away the fact we should be using Pythagorean theorem. Because what we'll actually end up creating then are two right triangles. So if this tower forms a right angle with the ground, you take the distance from the ground over to the bottom of the cable, and then the cable up to the top of the tower. We can certainly see we have a right triangle. In fact, we do have two of them, because here's the second one that kind of overlays it. And so even though these problems are kind of overlaid, they're still kind of separate problems. And there's a couple traps here, but nothing that we can't handle, nothing we haven't seen before. So let's start with the green one. I'm actually going to redraw this. I think that'll make the problem a little more clear. And so here's the small one, and we can grab some labels off here. So that's 50. Here's 22 feet, and we're trying to find the value of x. And so we're given two or three sides of a right triangle. Trig is unnecessary here. We can just jump right into the Pythagorean theorem. A squared plus b squared equals c squared. Okay. So now doing some substitution for the problem. Again, the values to choose for a and b don't matter as long as they're not the hypotenuse. So I'll choose 50 to be a, we have 22 to be b, and the c squared is just what we're trying to find. So I'll replace it with that x. So squaring of values, it will give us 2,500 for the first. Let's see, 22 squared gives us 484, and that's equal to x squared. And so we'll add our original total to 2,500 and get 2984, and then get rid of that square. Of course, we'll square root, which would give our first cable value approximating, and we have to round this one off, 44.54, excuse me, 0.626. Now, before moving on to second, of course, we should go back and ask ourselves, is that a valid value? Well, the cable does serve as a hypotenuse. The hypotenuse is larger than 50, so at least it does a preliminary check. We can repeat the process for the second. There is a little trap here, but we can get over that pretty quick. So redrawing our triangle, the tower is still 50 feet tall. The cable we're still trying to find, I'll label that as a y, and then we need the distance on the bottom. Again, the temptation is to call this distance 26, but if you look at the original drawing, the bottom distance is given to us in two chunks, 22 and 26, and so it's actually going to be 48. It's the result of the addition. But once we've cleared that hurdle, now we're just back into our old friend, the Pythagorean theorem. So we'll substitute 50 here, 48 here, and then y for our c. And so 50 again is going to be that 2,500 value. We square 48, what are we, 2304, and that's equals that y squared. Adding the two terms on the left together, we end up with 4804. Then, of course, square rooting to get rid of that square. That leaves a second cable with to be about 69.311 feet. Then, just doing a quick check for validity, it's definitely larger than 50, so it checks the hypotenuse test. And given the diagram, it should actually be larger than cable 1, and so it is 69 versus 54, and so everything seems to be okay. Number 8 asks us to find the perimeter of the figure below. So the perimeter, something to note, is that we have with this proportional right triangle, kind of type of problem again. The perimeter is found by simply adding the three pieces together. And so our job is to make sure that we have all three values. Some of this is actually given. If we look at the bottom, even though it's given in two chunks, it is given as a total value of 9. And so we're actually part of the way there. The temptation on the green side is that you might want to call that 4, but 4 is actually straight up and down, and so the 4 distance actually transfers to the middle. This is 4 centimeters. And so we don't actually have a value for the green yet, but I think using Pythagorean theorem we can find it. And the blue, well, we're just going to do the same type of thing. And so let's find green first. And so I'm going to label this x. Ooh, wow. I'm just going to label this x just so we're on the same page of what we're trying to find. So we need two pieces of this right triangle to use the Pythagorean theorem to find the third. But we can take the 2 centimeter value and use it for the bottom, and then solving for x um, for this triangle, for 4 here and for 2 here. Looks like, again, a direct Pythagorean theorem problem because it's a right triangle with two values given. And so looking at a squared plus b squared equals c squared, the a squared value should be used as 4, the b we can use 2, and now be x squared. And so we're looking at 16 plus 4 is equal to x squared, and it's 20 is equal to x squared. So when we square roots, and we take the square root of 20, we get x to be, again, we're going to have to round here, 4.472. So we can immediately jump into the blue. Again, I'm going to kind of redraw the triangle so we have a sense of what we're talking about. We can use a 4 in the middle. The bottom is 7. That's given, and we're just trying to find that last value of y. So again, Pythagorean theorem is appropriate. So 4 squared plus 7 squared is equal to y squared. Let's see, so that'll be 16 plus 49 is equal to y squared. 49, 65. And then square root to finish our problem. The y value in this case is 8.062. Okay, now we're not done yet because they actually did ask us to find the perimeter. But now that we have all three values, we have 9 for the bottom, we have 4.472 for the right, and then we have 8.062 for the top. Our job is now simply to add them together because the perimeter is the sum total of these three numbers, sum total of these three sides. So take 8.062 plus 9 plus 4.472. 4.472. And our final perimeter here is 21.53. 534. Okay. So even though they asked for perimeter, Pythagorean theorem was still the thing, which will be the thing here for this last problem as well. This one's probably the most straightforward of all three. We just need to solve for x. And so if we jump right into the Pythagorean theorem, a squared plus b squared equals c squared, there is one small trap that is possible here, and that's misjudging which value goes where. Keep in mind that the hypotenuse, the largest side, the one across on the right angle, must also always be the c value, so 100 must go in for c. Other than that, the order doesn't matter, so we can put 80 on this for a. We'll have to use x for b, and that will equal 100 squared for c. So we're dealing with some pretty large values here. 80 squared should be 6,400 plus x squared, and then we have 100 squared, which would be 10,000. Solving now algebraically, we'll subtract 6,400. Leaving us with x squared to be 3,600. Square rooting. The x value will be left at 60. And again, doing a quick check just for see if this answer is even reasonable. It is not the hypotenuse, so it should be smaller than 100, which it is. And if you look at the three numbers together, they're reasonably close. So we should have confidence in our answer. Okay? So that would be part 3. Part 4 will cover the algebra. So I'll see you then.